Okay, let's get this kata started. We're going to begin writing the scorer function. What the scorer does is it starts by taking a stream of rolls from the bowler, that is a set of numbers that correspond to the number of pins dropped for each roll that the bowler made, and it will return a stream of the scores, one for each frame that has been scored so far. Let's go ahead and start writing the code. Oh, right. Our discipline doesn't let us write a line of code, not a lick of code, until we first have a failing test. And that may involve some faking it until you make it, but let's go ahead and write our first test. Our first test is simply going to be FRP Bowling Kata scorer. And we're going to go ahead and run a file called the scorer tests. And that should be it. No, I guess we have to actually write some stuff. So the first thing we're going to do is we're going to import test because we need to tell it where we're going to find it. And that's going to come out of our test suite. And we're also going to have to import the scorer tests. And that's going to come in from scorer.spec. And now it's complaining. Well, why is it complaining? We know why it's complaining. It's complaining because, in fact, we have never written the scorer test. So it can't find the module. We're going to have to make one. And it should export the scorer tests. So let's go ahead and write scorer.spec. And let's export function scorer tests. And there it is. We're actually green. Well, that's not good. We're trying to get red, but we're green because we have the tester working, and it's actually not running any tests because there aren't any for it to run. So let's go ahead and let's write a test. So the first test we're going to write is, and you try for the first test, the simplest, most trivial thing that you can easily make work, and that would be the empty game, where the bowler hasn't rolled anything. And now what we're going to do is we're going to give the scorer, we're going to expect the scorer of, I guess we'll give it the empty observable. And we'll talk a little bit about that later. And the expectation from that is we're going to expect that to return a stream which will have the marble diagram for the empty stream. And of course it's got some problems with us, and that's not surprising. We haven't given it the observable. That comes from the RxJS library, and we need to import the test and expectation operators from the test suite. And then finally we need to give it the scorer. And that'll come from the scorer file. This happens all the time in tests for just development. You go ahead and you write your test about code that doesn't exist, doesn't have anything to do with anything. And eventually, from that process, that code will evolve. Okay, well, it's complaining again. And what is it complaining about? We haven't written score. Let's go ahead and write the score. And from that, we're going to export function score. Again, ending the dollar. The dollar at the end of a variable or a function indicates that the output of the function or the variable is a stream. It's just a convention we use to keep track of what's going on. Again, we let the compiler tell us what to do next. It's kind of like having tests, that getting it to compile is the first thing we need to do. It says that the supplied parameters do not match any signature of the call target. That means we haven't defined a function parameter that we used in the test. And then finally it says undefined is not a stream. We're not returning a stream. So let's go ahead and give it a stream that we simply can't complain about actually writing code, because it's going to say there is no code here, and we're going to throw it as an error. And what happens? It says observable is not defined. Well, that's because we haven't defined it here. And we should be there. Look, we're red. Why should I be so joyous that we're red? Well, I'm joyous because we have a test that says we need to have this function take whatever parameter it does and throw an empty observable, not the regular thing. So let's go ahead and find the throw and use the empty function there. And that will generate an observable, which is the empty observable. And that will have, in fact, the marble diagram that we had in our tests. And so this should be green, and it is. Congratulations, we just passed our first test. And so now it's time to refactor. And we're going to go and refactor in a couple of ways. It's still complaining from the thing we fixed there. We're going to make the lint happy, and that's our first bit of refactoring. Second bit of refactoring is a little deeper. What we're going to do is we're going to try to rewrite this using a function which will tell us by looking at a glance what we're testing. And so here we're going to go and we're going to test score. And we're going to say that when you give it a empty observable, at the beginning you're going to get an empty result. No biggie. But first we need to write test score. And it's basically going to be a derivation from the test we've already written. So I'm going to go in function, and we're going to say test score. And it's going to take a roles parameter, and it's going to have an expected parameter. That's going to be the marble diagram for the roles and the marble diagram for the expected. We know over here we meant for this to be expected. And over here, we're going to have to do something a little bit more sophisticated. Actually, let's do it up here. Let's say constant roles stream is going to be equal. And we're going to use now the marble to stream function that I showed you about when I was explaining how test stream worked. And we're going to give it roles. And then we're just going to put that here. So we're going to expect score.roles to marble to expected. And that should still be green. We've not changed the functionality. We've just made it green. And simpler. And now it's complaining that it can't find some stuff because we didn't get the marble to stream function. And I actually misspelled it because we have that $sign convention. And now we've got another error coming here. It says test is not a function, and that's because up here we know that test has to have a function for its second element. But I really don't want to have to put, I could just do that every time I write this code. But why not just have this test score return a function? And now I don't need to put a function in for the second element here. So we're back to having passed a single test, and it's time to write a second test. I realize it took a while for us to get here, but we're not going to have to see this again. What's the next simplest idea? Well, how about a single gutter ball? And we're going to just put that in here and in here. And we're back to red because we're responding with an empty array no matter what the input. We need to respond to something that's responsive to the input. We're giving a different input each time. But notice if you look at these two tests that essentially we're doing the same thing in each case. We're simply returning the input as its output. Now, I don't think that's going to be easy for long, but it is all we need to do to pass this test is to simply return what they gave us. And that should bring us green, and it does. And now the part of us that was writing tests is a little perturbed because that's kind of a cop-out. So let's go ahead and give it another test. You know, that solution he has is going to work for any one of these single pin drops. How about an open frame? So we're going to have 0 and then another gutter ball, and we would end up with the same result. And the difference is this is not going to pass because it's going to return the original, which has 2 zeros, not the single 0. And so we're going to need to do something else. We need to not return all of the content of roles. We just need to return the first element. Again, this doesn't seem deep, but it should bring us green, and it does. Okay, now we can refactor. We're going to solve the lint and get rid of the observable definition there since we don't need it anymore. And there's no linting here, so we're ready to move on to the next test. So we're even more annoyed than we were the first time. We're sort of sitting here as a test writer trying to get past the functionality that the other code writer had built. And, you know, think of us as having a conversation with ourselves, playing a chessboard from both sides. Or imagine Gollum from Lord of the Rings, who hates himself, but he's having this conversation with himself about everything. And that's pretty much what we're doing. We're writing tests and solving them with trivial solutions and then writing annoying more tests, and that's eventually going to get us really to a fairly beautiful piece of code, and that's what we're trying to do. So, Smeagol, what do we do? Oh, gosh, I just can't stand this. Well, what happens if I change that second one? He doesn't look at the second one, and that gives us the 1, and so that's not going to pass because take 1 doesn't do that. Well, the other Gollum comes out here and he says, okay, well, that's not a problem. I'll just go ahead and take the last one. And this is the process in test-first development. It seems a little glacial at first, but it's going to move, and it's going to move quickly. Smeagol comes here and says, yeah, well, okay, that's fine. I'm going to do that instead and that, and you're just not going to be able to take anything to get this result from this stream. We're red, and now we're seeing that we're going to need to do something other than a take. How are we going to get that? Well, the answer, I think we see the answers. We want to add that all up. And there is a way in Rx to go ahead and do this. RxJS allows us to reduce with an accumulator and a current value and get from it the sum. And we're green. So red, green, refactor, and there is a refactoring. This is kind of difficult to understand the way it is, so we're going to just take that code there and replace it with a constant sum, which is going to be a function. And we're green again. We weren't doing anything different. We're just refactoring to make it a little prettier and clear what our intentions were. Okay, so it's time for yet another test. Well, you know, we've actually solved it. We're doing open scores, but that's not going to work all the time. What happens if there are 2 open frames? Well, it's going to add them all up and give a single number, which is 2 in this case. But that's not right because we're not actually giving a different score for each frame. And so we're going to need to find a new way to broaden the scope of what we're doing here. This reducing over just the entire stream isn't enough. There's another way we can do this. There's a straightforward operator in Rx that will take a window and break the stream into a stream of streams, each of which has a count of 2. So let me explain what's going on here. We've got 0, 0, 1, 1. And what window count is going to do is going to break that up into a stream of streams. So there'll be 2 streams. And that second stream there is going to go 1, 1. And that first stream is going to be the 0, 0. And of course, when we did set up window count, we made it more difficult for us to be able to do any of this. But now what we're going to do is we're going to use a function called merge map. And those of you who've worked in other functional programming languages know what flat map does, and it's essentially the same thing. I'm going to start that with a period there. And we're going to give a function. We're going to give a function that's going to take frames, which is the name of the stream that we did in each case. And then what we're going to return from that is a frame. And then we go ahead and reduce that the same way we did here. Get rid of that semicolon. And that really ought to take us pretty much where we're going. I think that would bring us green, wouldn't it? Yes, we're green. Okay, so now we're going to satisfy lint. It's part of our refactoring. And we're good to go. Let's go back to the tests. It's time to write another test. Sorry, Smeagol, I got you licked. And indeed, it looks like he does, but Smeagol's smiling. Why is he smiling? Well, because there's another way to make it hard for us. Let's have 1s and then 2s. You see, we're keeping a running score, not just scoring each frame. And therefore, we're going to have not only 2 and not 4 here, we want that to be 6. And I bet you it's going to be 2, 4 that he returns. And it is. Okay, so we're going to need to do something else. What do we do when we have a stream of frames, scores, but we want to keep them in a running score rather than individually? Well, okay, back to our RxJS. We're going to scan, which works almost exactly like reduce, except instead of making a stream containing the result of the operation, it's going to show a stream containing the value at each step. Well, how do I do that? Let's go ahead and let's just go ahead and scan for the sum. And it's good. So what we've done is we've taken the stream that comes out from here, which is going to be 2, 4, and then we're going to go through this loop every time, and for each one of these we're going to produce the sum so far. So that generates the sum 2 from the first one, and then add 2 to 4, 6 for the second one. And that's why that's working now. Okay, well, now it's time for us to go back and see what we can do for our tests. What have we got? Smeagol, what have you got for us? Well, we've got 1 open frame, 2 open frame. I guess we're going to try to have to get more sophisticated because I think you've got any number of open frames. Well, what happens when we have a spare? Yes, let's make a spare. All right, so we have 3 5s, and that would generate scores of 15 and 20. The way spares work, if you remember, it's going to be 10 pins for the first frame, plus the next roll, which is 5 or 15. And so that would give us 15 for the first frame, and then we'd have 5 in the second frame so far for the partial open frame, and that brings us to 20. So and there we are. We're red. So now we've got to figure out a way to handle this frame scoring to give a 5-point bonus for that first frame. So we're actually going to do it in the simplest darn way that we possibly can. We're going to replace the sum with a different function. And we're going to do it by basically taking first a test. If the sum of those elements is 10, we're going to want to respond with a 15. Actually, let me just write it this way, because that'll help give us a sense of what's going on. And then just add them up this way to get the result otherwise. Now, notice I did the slime, the constant, rather than doing something else. And the reason is that's another step. It's a little bit more complicated. It may involve something more. And I'd rather see the structure, the shape of what we need here first, and make sure that that test passes. So let me give you an idea of what I mean. I look at this and we're green. So now we're able to go forward and write another test. As the tests get more specific, the code gets more generic. And here it's not so hard to figure out where we're going. Smeagol's way ahead of us. When you use just a different number, 559, 1928. And here we're running into a problem with our first design strategy. We're red, so we can write some code. Let's go ahead and just plug these numbers in here. And the problem here is what we have done is we've broken it out so that the frame we're scoring up here doesn't have any access, any look ahead to the 9 from the second frame. And that's going to be a serious problem. We're going to need to solve that by somehow keeping the 559 information available when we're doing the first frame. And it turns out there is a nice function that RxJS gives us, and it's called buffer count. I'm going to give it these parameters, and that's basically going to say, I want you to break this out into arrays of 3 or fewer elements representing each roll. So the 559 is going to be an array of 559. The 1 means that my second element is going to be just one roll deeper in the list. So what this is going to do is it's going to give me the array 559, and then after that it's going to give me the 59, and then for the last one it's just going to be the 9. And let's see what this would look like. 559, the array, followed by 59, the array, followed by 9, the array. And so now the combination of these two gives us the same information. The first element is always the roll that we're representing, and then look-aheads to the next 2 rolls. If there are 2 rolls, if there's only one more roll, we'll get a look-ahead for just one roll, and then here we just have 9 because it's the last element. And what it also shows me is that we really only need the first element of this frame. So let's go ahead and change up this code a little bit. We're going to take the frame, and then we're going to take 1. And then underneath it, we're just, instead of reducing over it, we're going to do a map. And it's going to be the trip, the particular 3-piece element there. And this is what I meant when I said we want to preserve the shape, get a good sense of what we're doing here. It's a trip that we're getting rather than ack and cur, so let's go ahead and use trip, the first element of the trip, plus the second element of the trip, and we need that to be equal to 10. Okay, and then now we can write this differently. We're going to say trip of 0 plus trip of 1 plus the trip of 2. And in fact, we have a way of saying that already. And what we're going to say is trip reduce sum. And then here we're going to say trip of 0 plus trip of 1. And that's almost all we'll need to make this work. It's not going to work, and it'll tell us why, but let's go ahead and run our code. And the problem is that we're getting not a number for the second frame, which is just a singleton 9, and adding to it undefined. And that gives us not a number. So what we really want to do, and really let's just do the simplest thing that could possibly work, and maybe it will. We're just going to take that if it's defined, and if it's not defined, we're going to give it a 0. And that might get us where we want to be. Just had to get rid of that little parenthesis, and all's well. We're green, so we can go ahead and do our linting. And we're green. And we just figured out how to do the spares. Isn't that terrific? It took us 2 tests to do it. That's not a problem. They don't charge us for those. At the end of the day, we forget all the tests that we've written. We are now ready to go ahead and write another test. What do you think we're going to write next? Sure. We're going to write the test for a strike. 10, 1, 2. And we're going to expect that to be 13 for the first frame, and then 3 more would be 16 for the second frame. Remember, the strike is going to be 10 pins plus the next 2 rolls. And so that ought to do it. And that won't work, I'm sure. That'll get us to red. And it fails. And it fails in a kind of really grievous way. I mean, the first frame is all wrong. It's 11. It's supposed to be 13. And 13, 16 is supposed to be the result we're going to be getting here for the actual scoring. So the first thing I'm wondering is how come we're not getting a 13? So let's go ahead and take a look, and actually take a look at our example. And now let's go ahead and run this through our code. Well, there's 13 if we were to go ahead and reduce the sum, but we're not going to do that because we're looking at, in the test, 10 plus 1, which is not 10, it's 11, so it's falling through, and it's just adding the first 2 numbers. So the first thing we need to do is actually just make a simple change here. We're going to look at trip of 0, and if that's equal to 10, or trip of 0 is equal plus trip of 1 is equal to 10. And oh boy, is this screaming out for refactoring, because I can't tell you what these magic numbers all mean. And that's exactly what refactoring is for, is to basically remove the magic numbers from our program, unless they're elucidating this. And let's see if that changes the first number. And now we're seeing the 13, 15. So the first frame is being handled correctly, but the second frame is only 2 pins, not 1 pins, and the reason is window count is failing us. A strike is a single roll frame, not a double roll frame, and so window count of 2 is just not going to be enough. We're going to need to find a better way to break it up. Let's go and see what we really want here. We want to break it up into a single roll by itself there, and then the next 2 rolls here. And that would get us 13 for the first frame, and then 1, 2 for the second frame, and that would be correct. So somehow we're going to need to replace window count with something else that's going to break us up from a stream of rolls into a stream of rolls. And it turns out there is a simple function that's provided in group by. It's a little more sophisticated. It's going to take a stream and it's going to put it together in groups that all have the same projection function. So they have, say, the same frame number. And then we're going to project out of it after each of these to get to our actual stream. Let's call that the trips. But first we need to figure out what we're going to be doing that with, and it's pretty simple. So let's take the first roll here, and what we would like to do is change that from just the array 10, 1, 2 to trip containing the array 10, 1, 2, and then frame, which will be 1. The second one is going to be the 1, 2 frame, which will be frame 2. And the third roll is going to be the 2 roll here, and it's going to be frame 2. So what group by would do is it would take this stream of objects, organize them into sub-objects or stream of streams, where they're all grouped with equal frames. And then the resulting objects in that stream of streams will be the trips. Okay, and that would get us this result here. Of course, we need to figure out how to break it up. And we're going to do that with a scan. And make frame over there. And that's going to be, let me just put it in here. Something. We're not going to put that in here yet. Let's start with what make frame is going to start with. It's going to start with an object having a trip and an object having a frame, which will initially start with 0 because we always start with the 0th frame. And we're going to need to keep some kind of information about whether it's the first or the second roll or the last roll of a frame. And so what we're going to do is we're just going to keep track of, is this the last roll of the frame, which will be true initially because there isn't any more for the 0th frame, and would be modified later. And we're going to actually define this function, at least initially, into, let's go ahead and put that there, which it requires for me to be able to make a distinction between an object and a block here. It's just a syntax thing. Trip is going to get the current. And frame is going to depend on whether it was the last roll or not. If it was the last roll, then we're going to make it the next frame. Otherwise, we're going to make it the same frame. And then how do we update last roll? For this, we're just going to try to duplicate what window count of 2 did. Just negate last roll. Right, so there's not frame, but m.frame there and m.trip there. And that ought to work and give us at least green for the all but the very, very last, the strike scenario, which is what we're looking for. And now we're ready to actually go ahead and handle the strike situation, which is way up here. And the question is, what do we do when we have current of 0 is equal to 10? Hold on, let me... Current of 0 is equal to 10, so that would be a strike. And in that case, we would write a strike object, which is, again, fairly straightforward. It's going to get its trip from the same place, and its frame is going to be just always frame plus 1, because that's the last roll of the frame, and the last roll is going to be true. Okay, and when we're done with that, we're going to make that happen. Let's go ahead and indent this to make it a little bit clearer, and also because there are spares which would end up with a 10 in the first roll. So let's go ahead and, what are we doing? Oh yeah, act.last roll. So when that's true, and that's true, we've got a strike. And when it's a strike frame, it's going to be just the one roll frame. Otherwise, it's going to be the two roll frame. And that should make us green. Let's see. No, not so much. Ah, yes. And now we're green. See how the compiler works with our test suite to help keep us honest and also to tell us pretty much where we've made our mistakes. And so now we're green, so we can refactor this a little bit. And that's pretty clear. Now we're going to make this a little bit sweeter, take care of these. Actually, when we have this idea of this trips, we're going to have is a strike. And so that would be trip of 0 equal to 10. And so here we can change that. Always make sure we haven't broken anything. And it says we have. So is strike of trip. Well, no, the parameter here is cur. And we're green, so that's worked out. I'm changing this make frame to mark frame, which is really what it's doing. And this make frame to mark frame. And now we've got a much, much better sense of what's going on. Let's get rid of some of these annotations. Take a look at the code and see what we've got. This doesn't need to be by itself. We can change that to score frame. Const score frame gets that. And I think we've made that clear too. Satisfy lint. And now we've got a pretty decent understanding of what our code is doing and why. There's still some refactoring we can do to explain things, but I think we're okay. We can actually take care of that here. And I think we want to make an is spare of trip. And so that's a little bit clearer now, and we can do a bunch more as we're going through this process. If that's a strike and that's a spare, I guess we could have a function that would indicate this take two. But let's move on for the moment. I think we've actually done a pretty decent job of making this code work. And let's go back and see if Smeagol can think of any other tests. And he can. He remembers our discussion about how scoring goes when you have a partial spare or a partial strike. That is to say, where you have a spare but you don't have the bonus pins. Now, one might think you should score that as the 10 and add the bonus later, but that's not the convention, and you know, conventions are irritating little things. But in fact, you don't score it at all. Actually, if you were to look at the score list, that score would disappear because it was a part score with 5, and then you added the other 5, and that now made it a spare. So let's go ahead and see what we can do to make that happen. Well, what's our code going to do? It actually does what we thought we might do. It gives us the 10. And the reason for that is that when you have these short frames, you're actually not adding. You've only got 2 numbers in the trip for 5, 5. So it's basically, when it does this reduce, it's not producing something to indicate that it's not adding another number. We can actually solve that easily. Okay, so once we get our trips here, what we're going to do is we're going to map that trip, if it's short, we're going to map that trip to concatenate it with double nans here. We don't need 3 because none of those arrays are going to be empty. And then what we're going to do is we're going to slice that and take the first 3 rolls out of it. So if we already had 3 rolls, we want to be back in the same place. So slice 0, 3 ought to do it. And that won't solve this problem because it's going to leave a nan there. But we can get rid of the nan scores easily enough. We're going to filter out our scores. We don't want any score that is an n. And that should bring us green. And it does. And there's one last example that we can think of. It's pretty obscure, but I found it. And this is going to be what happens when you have a full spare game. We're going to get test score. I'm going to take a big game where we're going to have a stream of 21 5s. And the result of that is basically 5 spare, 5 spare, 5 spare, 5 spare. And the result of that is going to be a stream which is going to give us 15 for the first frame, 30 for the second frame, 45 for the second, and so forth. And it doesn't work. And the reason it doesn't work is it actually has that 5 hanging around as the 11th frame. It's a partial open frame, so it does score it, and the problem is it's an 11th frame. We don't want that to be there showing up in our game. So how do we solve that? Well, it turns out, again, it's pretty easy. What we don't want is an 11th frame, so we're just going to take 10. And now we're green. And now we've completed the scorer. We've actually written the entire scorer application, a portion of the application. This is actually the classical bowling kata. It's done in a broader way because we're showing rolls as they go along and doing some checking that they don't do in the kata. But this is, while a little more sophisticated than the classical bowling kata, we've solved this. Next thing we're going to do is the displayer, which is going to take the stream of rolls, the same stream of rolls, and produce the actual appearances of the rolls as they will appear. And then we're going to do the enabler, which is going to show which buttons should be available at any point. And then we're ready to write our UI and produce the application that you saw at the beginning of this Screencast. So there it is, the scorer, and now it's time to move on to the displayer.